So here we have a transmitting circuit. We have two inputs, the phone and the microphone. And the microphone, the output, is connected to an operational amplifier, which is powered by 9 volts and grounded on the other end. We also see roughly 5 volts connected to the positive end, and that 5 volts is generated through a voltage divider. And this output is essentially amplified through this 100 ohm resistor, and that represents negative feedback. And that amplified output is sent through this 10 ohm and this second 10 ohm resistor, which also goes through this 10 microfarad capacitor. And now the phone is connected via an auxiliary cable, and one end is grounded as the other end is connected to a 0.47 microfarad capacitor and a 680 ohm resistor. And now those two signals from the phone and the microphone are both mixed and sent into this second operational amplifier. This op-amp is also powered by 9 volts and grounded on one end, and we also see 5 volts coming into the positive end through another voltage divider. This output is then amplified even more through a 4,000 ohm resistor, and we see an even greater gain. And now we approach this 10 microfarad capacitor and 2.2 millihenry inductor. And right now we can see that this component represents a bias T, and bias T consists of a capacitor and an inductor, which deals with AC signal and DC signal and essentially protects your signal source. In our case, it's the phone, and it also prevents DC current from flowing back. So the output is connected to this 10 microfarad capacitor, and through the capacitor we see AC current, and then in this branch we see the inductor, the 100 ohm resistor, and 9 volts coming from our source. This branch generates DC current, and these two currents are combined, and right here, right at this node, we see around 4.5 to 5 volts, and that DC voltage is what powers our signal. Before our signal goes to the laser, it's sent through this 100 ohm resistor, which essentially just protects the laser from high currents, and the signal is sent to our receiving circuit.
So here we have the transmitting circuit, and we begin with the mic right here, which is connected to this op amp. And the reason we did this was because we wanted the voltage of the mic to equal the voltage of the phone. So as we have this op amp right here, one end is grounded, while the other end is connected to the 9 volt battery. So as we continue on, the op amp is connected to a 10 ohm resistor, which is connected to a 10 microfarad capacitor, and goes to another 10 ohm resistor. And we have this node right here where one end is coming from the op amp, and the other end is coming from the phone, and the phone's connected through this aux cord that's connected to the 0.47 microfarad capacitor and a 680 ohm resistor. So as we continue on, we have another op amp right here, and on one end of the op amp it is connected to the 9 volt battery, and the other end is grounded, and this op amp has a feedback loop of 4,000 ohms. So then the op amp is connected to a 10 microfarad capacitor, and as we continue on, we go to the bias T, which consists of a 2.2 millihenry inductor, which is connected to an 100 ohm resistor, and then connected also to the 9 volt battery. And so then we connected the bias T to another 100 ohm resistor to help dissipate the current, and this results in the laser.
So here we have our receiving circuit. The lasers that are transmitted by the transmitting circuit are absorbed by the solar cell, which is a device that generates a voltage when it's exposed to light. And that signal is sent through a 2 microfarad capacitor and a 100 ohm resistor, and that signal is sent into the inverting terminal of an op amp. This op amp is also powered by 9 volts and grounded on one end. And through the positive terminal we send 4.5 volts, which we generate through a voltage divider. And then the output of the op amp is sent back through negative feedback to a 7.6 kilo ohm resistor, which gives us a huge gain, and that output is sent through a 10 microfarad capacitor, which is then sent to the speaker where our signal, or essentially our song that we're playing, is outputted or played by the speaker. And the speaker has an 8 ohm internal resistance.
So here we have the receiving circuit, which begins with a laser hitting this pin diode, and the pin diode is connected to two 1 microfarad capacitors, which are parallel, which is then connected to an 100 ohm resistor, and then this goes to an op amp right here, where one end is connected to the 9 volt battery and the other end is grounded, and this has a 7600 ohm feedback loop. So this op amp is connected to a 10 microfarad capacitor, which goes through to the speaker and eventually creates the music.